Hello, and thank you for joining this session within our world of electrification and automation. I am Michaela Mönikes, and our next speaker here is my dear colleague Jorge Diaz with a how-to session on SIAPP. And you can already see that we have now some hardware here in the studio. Jorge brought a PC with him, and here's a little device over there, a SICAM A8000, and Jorge will present how to create an application with SIAPP. Please post your question at any time during the presentation. We will answer them live at the end of the presentation in our dedicated Q&A session. You already know I will read your questions aloud and then address them to Jorge. Please make use of this possibility to directly address the expert. Jorge and me, we are here just for you. And yes, we do record this session. And yes, you will get access to it. Jorge, I know that you would like to focus on how to write your own application for SICAM A8000. And I hope that the auditorium is curious to learn about SIAPP. Jorge, the stage is yours.
Thank you, Michaela. So, as Michaela explained, I will try to show you how you can write your own SIAPP, your own application that could run in the hardware of the SICAM A8000. And I am not a developer, so we will use the tools available in the software development kit, and of course, a developer will be able to do wonderful things. If I can do this small exercise, just can imagine what an actual developer can do with our wonderful tool. So let's start by describing the exercise that we want to perform today. We have a CP8050, okay? And in this CP8050, we will have one port to configure the RTU, and we have configured one floating point set point. And we also have one measurement. The idea is normally if we want to write the set point from the web browser of the from SICAM web, then the measurement should get the value written by the set point. This you could do normally with a CFC function, for example, but we can also do it with a SIAPP. So this is the exercise we will do. We will create a SIAPP application runtime, and there we will configure one slot for our SIAPP, and through the API interface, we will write the value that we set in the set point to the SIAPP. And we will write the SIAPP, so this value will be written to a variable mass out, and through the API will be written back in the measurement. So at the end, we will see that this is written in the RTU. Okay, so here we have our RTU, and here I have already pre-configured the RTU, the dashboard. So I'm connected here to the RTU, and I have the set point and I have the measurement. So if I send the value, for example, 50, then I expect the value to be written here. This is not yet. It's not done yet. We will create the SIAPP to do that. Okay. So what should we do? First thing that we will do in this case is we will prepare the RTU to work with the SIAPP. So we will go in the CP8050, where we have here firmware and licenses, and we will go to SICAM application runtimes. By the way, this is SICAM Device Manager, of course, the software that is used to configure the RTUs to be able to load also the SIAPPs there. So we go here in firmware to SICAM application runtimes, and we will add one SICAM application runtime. This is that you need normally a license. We will work in demo mode. So we have 3 weeks to finish the demonstration. I hope we will manage today. So it has been loaded here. The firmware is there configured. Perfect. I can save Now I will go back home, and then I will go to SIAPP configuration. So in SIAPP configuration, I can see the SIAPP runtime environment that we created already there, and I can set a name if I want. I like this name, so I will not change it. And it is suggesting me to set a RAM limit, a CPU share for that. The application we will create is quite small, so we can live with these default values, no problem. We could also define a port in the RTU to directly interact, so the SIAPP can interact directly with the outside world. In this case, we don't need it. The communication will be directly between the RTU and the SIAPP via API interface. So we don't have to define a port here. And now we go here to SIAPPs. We will create one slot for the SIAPP. Okay, we will say, okay, it's activated. We want the SIAPP to start. We can define in which application runtime it will run, the only one that we have created, so it's fine. Memory, we can leave it like that at the moment. Fast formatting, yes. Behavior, in case there is an error, we want it to restart. And we want to exchange information via the API interface, so signals, read, write, set to yes. Perfect. So now we should define which signals will be exchanged between the RTU and the SIAPP. So we will go to signals. We see that in the whole RTU, we have only these two signals. One is the set point, floating point, set point, type 50 according to 104 protocol, and the measurement out, type 36 floating point according to 104. Perfect. So they are mapped to the dashboard, what I already showed you. So we will map them. We will map the set point first to the central processing, and we will assign as processing type SIAPP 0 input. This means this set point will be written from the RTU to the SIAPP. And then I will go to parameter, and I will look for SIAPP 0 input. And I can define here the name how this signal will be known in the SIAPP. So let's say set point in, for example. Could be the same name that we have here, but could be different. Okay, perfect. Now I will assign the output, the measurement, to the central processing. And we will assign this to be SIAPP 0 output, which means the SIAPP will write this value back into the RTU. And I will go to parameter, SIAPP 0 output, and I can put a name, how it will be known in the RTU. This is all we have to do at this point in the configuration of the RTU. So we can just try now to load this data in the RTU. And while the program is being loaded into the RTU, let's go and try to write a SIAPP to do what we want to do. Okay, so the first thing we need to do is go with a web browser. You must be connected to internet, and you go to the GitHub webpage where we have our software developer kit for SIAPPs. Is this webpage that you see here. From there, you can see that we have here this example. This is the software developer kit, and there are also some descriptions of what to be done. Okay. There are some examples there that we will use to perform the SIAPP that we want to do today. So, perfect. If we go below, there are some descriptions about what to do in order to create the SIAPP, to duplicate this software developer kit in your computer. Okay? So basically, if you go here to the example, it tells you that you should define maybe a folder in your computer. Here I created C, Word of Energy, and I have a folder, my first SIAPP. So I will download the software developer kit here. And then I will open the Windows PowerShell. You could also use the any command prompt window, no problem. And here we will have to navigate to this path here. So I can just copy the path, and then I navigate here by saying CD, this means change directory, and then, so right now in this Windows PowerShell, we are in this folder. And now we copy the command to clone the software developer kit, which is this one. Copy and enter. You will see now that in this previously empty folder, we have the software developer kit. Okay. Meanwhile, I will check the RTU is ready to restart. So I will just say continue, and we will continue here with the development of the application. So this is the software developer kit. And this software developer kit has several examples, program examples. We will use one example that is in these code snippets. So I will just duplicate these code snippets, copy the whole folder and paste. And I will rename the folder with my first SIAPP. Okay, so now let's see what is in there. Here we have a folder with the software developer kit with the SIAPP interface. So this has all the libraries that the RTU needs to be able to read to exchange information directly with the SIAPP. Here in SRC, this means source, is the source code that we want to pack into our SIAPP. And here, this is a text file, which aim is to give the instructions for the SIAPP, which programs should be packed into this application. Okay, I will start by editing this one. This code snippets, SIAPP, basically, it has a SSH daemon, a secure shell protocol daemon, and with this, in theory, if we can establish communication with the RTU through this SSH daemon, then we can just give instructions to start some programs that are there. And one of the programs that is written there allows you to write the value of one input into one output, which is exactly what we want to do in this case. So we will use this program. Okay? Is this what we call a simple DIDO? But it also has a lot of stuff that we don't need, because in this case, we don't want to use this SSH daemon. So I will just edit and remove from this file what I don't need. So I don't need to have interface with the external, what I don't need to have an IP address in this case. So I will remove this first part. This part I will leave because we want to use the libraries for C++, which is the language that is used in the SIAPP. So we will leave that. All this part here basically is related to this SSH daemon. So we will remove this part as well. So we can just remove this. Then, so it is what this instruction file is saying is, first, we will build the SIAPP as per this system architecture, Alpine. It will include the libraries of C++. It will copy the file source codes that we have into the SIAPP. It will code the SIAPP. So the API interface files will be copied also in the SIAPP. And then this file will compile one of these programs that was included in this example, which is called Hello SIAPP. We don't need for this example, so I will remove it. The next one, it will compile basically the simple IDO. It's also including the Edge Data API and helper. This is also using in this program, so we will leave all this line as it is. The next line is a program also included in this example to subscribe. We don't need this in this example. And then this one, discover, we also don't need this in this example. So we will remove them. So with that, is done for this file. Only one thing is missing. As said before, the idea of this application was to start a SSH protocol daemon. So we can start the simple DIDO program from a control panel, from a command prompt. We want it to start automatically in this example. So I will remove this last file. I will replace it with entry point. And then the name of the program that we have is this one. So we want that it will tell the SIAPP when we build it that it should start automatically this program. So with this, we have already told the system how to build the SIAPP. Now we should go to the code where we write the code. So let's go to SRC. Here we see a lot of program codes, one for this discover program, which we just erased from the instructions. So we can just remove it. Hello SIAPP. Nice to have. We are not using it, so erase it. These two we will leave because these are called actually from the simple IDO. We will see where. And this subscribe we are not using. Remove. So far we have only this simple IDO. So this program, as I explained before, the idea is to take one input signal in the SIAPP and write the value in one output signal. So basically, it is calling here some libraries, and it is starting this helper. So this is why we are leaving this part here as well. And it has, to make it easy, a definition here of the name of the signal that is going into the SIAPP and the signal going out. So we can just replace this with the values that we use in the configuration. So let's go here in signals. Parameter SIAPP input. So we have this. I will copy this to make sure I have the right value, and I will write it here. And this is the value that will be written back from the SIAPP. So let's go to SIAPP slot 0 output. Basically, that's it. Let's take a quick view of the file. We will not take a look line by line. Your developers will be able to understand exactly everything that is in there. I will just go through a general overview of what is in this main file, which describes the program. Basically, it establishes the connection between the program and the RTU via the SIAPP, between the SIAPP and the RTU. And then it establishes a data handle, which means basically it's a memory address for the input that is read. So right now we have this handle. The handle is referring now to this input signal that we have here. And then later it defines a pointer to this memory place. So through this, basically now when we are referring to this, we are referring PDI data. At the end, we are talking about this address here. And the same is done with the output. Data handle and memory assignment for the output, then a pointer to this memory address. And from now on, then when we handle the pointer, when we manipulate the pointer, we are manipulating or reading this address. Then it is using here is checking that the value through this helper is equal value, which is also located in another file. Sorry. In this file, it is using this program. It's checking that the input and output values are different. If it is the case, then it will write here. Here it will write in the output the value of the input, and it will write in the output the quality of the input. That's all the program does. Perfect. So now let's compile our SIAPP. So what do? We go again to your command prompt or PowerShell. We will navigate to, because we are at the moment in my first SIAPP, we will navigate to the software developer kit. So cd SIAPP. We are now inside of the software developer kit. And now to compile it, you have also here the instructions here, how it is done. I will just do it here. I will show here maybe. There is this program. Build.py. So it's a Python program. So we need to run it through a Python command. So Python, then we build.py, and then the name of the application we're building, which is my first SIAPP. Then the program starts being compiled. We will see that now in the software developer kit, a folder called build has been created. And now software is being. Now we have here under build, my first SIAPP, we have the software there. Now we can do something quite nice. We could just open the RTU online and load the SIAPP there directly. But we can also load the SIAPP application directly in SICAM Device Manager. So far we have here in SIAPP configuration, we have defined the slot, but there is no program running yet, no SIAPP loaded. So I will close the tab, and in SICAM Device Manager, I will say SIAPP, and I will say import. And then we will go to C, port of energy, my first SIAPP, build, my first SIAPP, and this is the SIAPP we just created. And we have imported now in the project, in Device Manager. So now I will go to the RTU and go to SIAPP configuration, SIAPPs, and I can just assign that this SIAPP is the one that I imported here. And now I can just load the RTU again. I hope I have not made any mistakes, and I hope it will run as we expect. If something doesn't work, then you can always blame my glasses because I forgot them today. So I'm working like a bat with the echo. So restart, good. Now I will access the RTU online. Okay. I can check here first if I will log in. in firmware. I can see if the SIAPP is running. Yes, it is running. This is good news. So let's go in the dashboard, and I will write the value 50. And now the value has been written in the output. So we have just written a small SIAPP. We have prepared the RTU. We have loaded it in the RTU, and it is doing what we expect it to do. So if you have one of our RTUs, CP8050, CP8031 with SICAM Device Manager, just by having access to the software developer kit, you will be able to do the same example, and you can also explore the other programs available in the software developer kit, and you will be able to perform your applications in no time. This is what I had prepared today as demonstration. So I guess right now we are ready to take your questions.
Thank you. The last point went faster than expected, but that was, if we wait for a system. And I thought, and we already have some questions. The first one is one I will take. Can we get a recorded video for this session? Yes, you do. It will be automatically available right after the presentation. And another question is, that was already read at the beginning of the presentation, is this application free?
All I did here, all I wrote, was based on the software developer kit, which is free of charge. It's available for you. You just have to enter into the GitHub web page, and you can just download it and use it for your application. So yes.
Okay. Oh, that was easy. And the next question is concerning storage size, I think, because the question is, what is the maximum size of a container to load into CP8050?
Yeah.
Is it saved on SD card?
It is not saved in the SD card. It is saved in the hard disk, in the memory of the CP8050, which is non-volatile memory. So it will be there, but it's not in the SD card. And there is a size, maybe we can share the screen, if possible. So when you create the software, the SICAM runtime environment, you define here a size. And here you have maximum 300. So you have 300 megabytes as hard drive space in the RTU for the CR. And you can, if you have only one CR, you can assign all the 300 megabytes for one. If you have two CRs, then you can share the 300 between both. So one with 250 and the other with 50, for example. If you have three, then maybe each one with 100, or one with 200 and the others with 50. 300 is the maximum size.
Okay, thanks. And now let's see, questions are running in. How diff more value? Oh, that looks like a question fragment. If MS has the chance to differentiate this question a little bit more and post it again, I think that would be helpful, because I didn't get it. Did you? With just these four, not how diff more value, that's, I think, too short. We'll wait if it comes again, and if not, will you be in the exhibition area?
Yes, of course.
Okay.
Tomorrow I will be, not the whole day.
That's okay.
But I will be on 3 of the slots, so almost all day.
So, and if not you, then we have other experts in the exhibition area. You have the chance to meet the experts directly via a Teams meeting, so you can ask your question audible, not having a typing and read it via me, but can ask experts which are waiting for you in the exhibition area. We continue the question round right here in studio. Is it necessary to buy a processor to train programming skills?
I mean, no. If you want, you don't need to have the CP8050 to write your SIAPP or to test it. And there is a possibility with the Docker desktop, which has been installed in this computer. You must follow the instructions in the software developer kit. If you have this, there is also a test environment where you can simulate the environment of the RTU. So no, just to learn how to program, you don't need it. But of course, at the end, if you want to run it to exchange data exactly with the RTU, it is like recommended.
Should have an RTU to be able to test with an RTU, I guess.
Yeah.
Yeah. And JC wants to know, are there any alternatives to the Siemens Device Manager?
No, if you want to use the SIAPPs in the SICAM A8000 family, you must use SICAM Device Manager. This functionality is not available for SICAM Toolbox.
Okay. And I think this question seems to come from a programmer. Can an application written in Python be converted into a SIAPP?
Basically, yes. You just need to include the proper routes to address the Python program. Actually, you can use any programming language that you want. You need to of course, you need to be a programmer and need to know exactly what to adapt, but of course it is possible.
Okay, thanks. And I think another question fits to the how can I test, how can I train? Are there SIAPP configuration trainings available?
No, there are in the Power Academy here. We don't have SIAPP training applications. This is a tool where we are offering the SIAPP runtime environment. This is a Siemens product. And what we are offering or giving you is the possibility to develop your own application. You need a developer who has knowledge in programming. And what is offered is a wide range of tools and descriptions in the software developer kit web page, where we are pretty sure any developer will be able to continue on its own. Of course, if you face specific issues, you can always contact us through our customer care and we will support you, of course.
Thank you. For now, I don't see any more questions in the line. I hope I didn't miss any, but seems like to be on the top of the list. So thanks a lot, dear auditorium, for your questions. Thanks, Jorge, for all your answers. Thank you for the possibility of being there tomorrow in the exhibition area, for chatting to you and talking to you. If questions come to your mind later, join us in the exhibition area or contact us on the webpage, via LinkedIn, whatever. We'll get back to you. And yes, we recorded the session and it will be available to you right after the session. So we have one more session for today on the line, and I'm looking forward to meet you there again. It will be my dear colleague Gustav Steinberg with another how-to session. He will present how to set up point-on-wave switching. And that's totally new for me, so I'll be there and listen in, and I hope you're going to do the same. Thanks, Jorge, for your time here.
Thank you.
Thank you for joining in. And goodbye for now.